Hello guys, welcome to Study for Civil Services. In this video we will see NCERT Class 9 Geography Chapter 4, that is Climate. And we have already covered all the chapters of NCERT Class 6, 7, 8 Geography. And we have also solved exercises given at the end of every chapter. And in the coming days we are going to cover NCERT from Class 6 to 12 for Economy, Polity, History and Geography. So in this chapter we will see some of the very important points, and we will also try to cover the exercises given at the end of the chapter. Although this chapter is very long, but we will try to cover as maximum as possible. So first of all, we will see some of the very basic definitions in this chapter, that you should know the difference between the weather and climate. Weather actually refers to the day-to-day changes, and it refers to the state of the atmosphere over an area at any point of time. But climate actually refers to the sum total of weather conditions and variations over a large area for a long period of time, and usually it is taken more than 30 years. So this is the main difference between weather and climate. Weather means day-to-day changes in temperature, then humidity, then rainfall, then atmospheric pressure, then wind. So all these day-to-day changes, because the we also see daily weather report in all the news channels. So these is known as weather. But if you collect all the weather conditions, and you take the average weather conditions for a larger area and for a longer period of time, this is known as the climate. And the elements which actually define either the weather or the climate, they are the same. There are six elements, that is temperature, then atmospheric pressure, then wind, then humidity and precipitation. So these are the elements which are common for the climate as well as weather. But out of these six elements, two are the most important, and they are temperature and precipitation. We will come to know that these two are the most important in deciding the weather and the climate, and the various type of climates across the globe as well as in India also. Now the world is actually divided into a number of climatic regions, and India's climate comes in the monsoon. So India's climate is also known as monsoon, and the word monsoon is actually derived from the Arabic word mausim, which literally means season. So monsoons actually refers to the seasonal reversal in the wind direction during a year. See, this monsoon concept is actually associated with the ITCZ, that is the Intertropical Convergence Zones. ITCZ means ITCZ is actually lying at around 5 degree north latitude of the equator, and it means that the wind coming from the northeast and the wind coming from the southeast, they actually converge in an area, and thereby resulting in the formation of ITCZ. So this whole lot of seasonal reversal of wind is actually associated with the movement of the ITCZ. And you can say that the apparent movement of sun with respect to earth takes place, and that which result into the movement of the ITCZ. Either if the ITCZ moves towards north uh, in the summer season. So if the summer happens, then the ITCZ will move towards the Tibet plateau in the area of around 20 to 25 degree latitude. So thereby, the northward movement of ITCZ, it result into the whole change of all the global winds, because ITCZ is the area where the wind from northeast and southeast converge. So if the ITCZ will move towards the north, whole global wind pattern will change, and that is why when they try to cross whatever the waves, they are coming in the southern hemisphere from the southeast direction. So when ITCs will move towards north, so they will also try to you know they will also try to cross the equator, and then the factor of Coriolis force comes, and thereby this southeast wind will be converted into the will be deflected towards the right, and thereby their direction will change from southeast to southwest, and that is why we are known as monsoon winds. They are known as monsoon winds, and they are coming from, it is said that they are southwest monsoon. So this is the whole phenomena of monsoon and the convergence of ITCZ, and all this happens because of the apparent movement of sun. The sun apparent movement is will be in the north direction in the summer season, and it will be in the south direction in the winter season. And the climate of the India is that therefore described as the monsoon type, and this monsoon type is actually found in the South Asian countries and the Southeast Asian countries. And despite an overall unity in the general pattern, there are perceptible regional variations in climatic conditions within the country. You can say that if you take two important elements, that is the temperature and precipitation, I have told you that these are the most important elements associated with the climate and weather. So you can see that the variation across the regions also present, because in summer sometimes the mercury or the temperature touch 50 degrees in some parts of Rajasthan desert and in some parts of Gujarat also, but it will be only 20-degree in the Jammu and Kashmir. And on a winter night, the temperature at Dras region in Jammu and Kashmir may reach low as minus 45 degrees Celsius. But Thiruvananthapuram, on the other hand, may have a temperature of 22 degree at the same day or same month or same time. And this is the fact that in certain places there is a wide difference between the day and night temperature. For example, in the Thar desert, the day temperature may rise up to 50 degrees Celsius, and then in the night time it will drop down to near 15 degree or near 10 degree. This happens because of the continentality effect, because land actually release heat very fast, and as well as land can be heated very fast. And this reason Thar desert is interior is located in the interior of the India, and it's completely inside the land, and that is why because of the continentality effect, these type of regions, their temperature may rise up to 50 degrees Celsius, and then they can drop down up to 15 degree also. But you can see hardly any difference in the day and night temperature in the Andaman and Nicobar Island or some places in the Kerala, because these regions are close to the oceans, and that is why because of the moderating effect of oceans, because of the moderating effects of sea breeze and land breeze, these regions they don't have any difference in the day and night temperature. And this is a fact you can remember for the exams, that as you move away from the equator, the difference or the contrast, the difference between the temperature in the day and night, or the difference between the time period of day and night, it actually decreases. So you cannot find any difference in the time period of day and night near the regions of equator. But as you move away from the equator, like in the regions of Jammu and Kashmir, there will be significant difference in the day time period and as well as in the night time period. Now, if you see at precipitation, there are variations not only in the form and type of precipitation. There may be snowfall, there may be sleet, there may be hail, but also in amount and seasonal distribution. And the precipitation is mostly in the form of snowfall. I've told you in the upper parts of Himalayas, but it rains over the rest of the country. And even the amount of precipitation varies across the regions in India. Like the annual precipitation, it varies from over 400 centimeter in Meghalaya, plus some of the other regions of northeast, plus some of the regions of western Ghats, to less than 10 centimeter in the Ladakh and western Rajasthan and some of the regions of Thar Desert. And also most part of the country actually receive rainfall or precipitation from the June to September. That is why this season is known as advancing monsoon or monsoon. But there are some exceptions also, like some parts of Tamil Nadu, they receive their major chunk of rainfall during the October and November. So the region of Tamil Nadu is the exception. Please remember it, because exceptions always being asked in the exams. And if you see in general, coastal areas they experience very less contrast in temperature conditions. I've told you, because in the daytime, the land dissipate heat. Land can be heated very fast. So at the daytime, the sea bridge travel from the ocean to the land area, so thereby moderating the temperature of the coastal regions. And in the night time, when land cools very fast, then the land bridge will move from land to the sea, so thereby their temperature their temperature always remains the same, and the contrast is very less. And seasonal contrasts are more in the interior of the country. For example, we have saw in the Thar region, because of the continentality effect. And this is also another fact, that there is a decrease in the rainfall generally as we move from east to west in the northern plains. And these variations have actually given rise to variety in the lives of people, in terms of the food what they eat, and in terms of the cloth they wear, and also the kind of houses they live in. You can see that this find out why the houses in the Rajasthan have thick wall and flat roofs, because to compensate, Rajasthan is very hot region and arid region, so they have thick walls and flat roofs, to compensate for the heating effect, and to survive from the heat, to survive from the direct sunlight or direct sunburn, their walls are very thick. And then why it is that the houses in the Terai and in the Goa and Mangalore have sloping roofs, because these regions have very high rainfall, so they have sloping roofs so that water should not accumulate it in the roofs. And then houses in the Assam are built on stilts, because their regions are always remains rainfall, and their regions always remain marshy type. So that is why the houses they are built on the stilts, and they look like the some of the sticks. Now, if you see about the climate control, there are actually six major controls of the climate of any place, and they are latitude, then altitude, then pressure and wind system, then distance from the sea, or it is also known as continentality. I've told you this thing, and then ocean current and relief features. So these are the six major controls of the climate of any place. Now, because of the curvature of the Earth, the amount of sun energy received, it varies according to the latitude. And like in the equator region, the sunlight will fall directly on the equator at the 90-degree angle. So that is why equator region is the region which receives maximum amount of sunlight. And because of this, the air temperature generally you know increase in the equator region, and then they create low pressure, and that is why in equator region daily rainfall happens. And then air temperature generally decreases from the equator towards the pole, because at equator the sunlight will fall directly and at the 90-degree angle. But as we move from equator towards the pole, the sun rays will be slanting, and that is why, because of the angle, the slanting sun rays will be towards the pole. And as one goes from the surface of the earth towards the higher latitude, the atmosphere become less dense and the temperature decreases. This we have already seen if, when we were analyzing the atmospheric layers like the troposphere, then stratosphere. As we move up above the, as we move up the height, the temperature starts decreasing in the troposphere, and that is why the hills are cooler during the summer. Now the third control is the pressure and wind system. The pressure and wind system of any area, it actually depend upon the latitude and altitude of that place, and that is why it influence the temperature and rainfall pattern. And then the continentality effect, because the sea exert a moderating influence on the climate. I've told you that there are two type of breezes, that is the land breeze and as well as the the land breeze as well as sea breeze. And as the distance from the sea increases, its moderating influence decreases, and the people experience extreme weather conditions in the interior of the land. And this condition is known as the continentality. That is, it remains very hot during the summers, and it becomes very cold during the winters. Then the other control for the climate is the ocean current. Ocean current actually, they come whenever they pass through any coast, or whenever they come along any onshore winds, they affect the climate of that particular coastal area. Suppose if any area, if warm current is passing nearby any area, then that area will be having the warming effect, and the reverse for the cold current. And finally, the sixth major control of climate of any place is the relief. And relief play a major role in determining the climate of a place. And high mountains, they actually act as a barrier for the cold and hot winds, and they may also cause precipitation if they are high enough and lie in the path of rain-bearing winds. For example, whenever the southwest wind, that is the monsoon wind, they they try to enter into India. So first of all, they will hit the Kerala coast, and then they will move towards the Western Ghats. So because of the enough height of Western Ghats, the west portion of the Western Ghats, they receive heavy rainfall, and because these mountains, they act as the active barrier in the monsoon winds. Now we'll see the factors which are affecting India's climate. The first factor is the latitude. See, the Tropic of Cancer actually passes through the middle of the country, and the Tropic of Cancer passes through 8 states. I've told you in the previous chapters, and it passes from the Rann of Kutch in west in the Gujarat region up to Mizoram in the east. And almost half of our India lies south of the Tropic of Cancer, and it belongs to tropical area. But the remaining area, that is the north of the tropic, it lies in the subtropics, and that is why India's climate is having the characteristic of tropical as well as subtropical. And in the Himalayas region, actually, the tropical plus subtropical plus temperate plus alpine plus tundra, every type of climate is present in the Himalayas, because our Himalayas height goes up to 8,000 meter. So because of the various glaciers present in the very in the greater Himalaya regions, which are more than 6,000 meter, so India's Himalayas are having the every type of climate is present in actually Himalayas. Then the second factor which affect the India's climate is the altitude. And India has actually mountains to the north which have an average height of around 6 kilometer, and India is also having vast coastal area of around 7516 kilometer length, including the Andaman Nicobar and as well as the Lakshadweep island, and its maximum elevation is also about 30 meters. And the Himalayas actually, they prevent the very cold wind which originate from the Central Asia as well as the Siberia region of the Russia. and they prevent these Himalayas, actually they prevent these type of cold winds from entering the Indian subcontinent. I've told you that Indian subcontinent consists of countries like India, Pakistan, Nepal, Bangladesh, and Bhutan. So these countries actually form a type of subcontinent because all the features of continents are almost present. So that is why it is known as the Indian subcontinent. And Himalayas, they always remains a active barrier to the cold wind originated from the Central Asia, and that is why because of our Himalayas, our Indian subcontinent experience comparatively milder winter if we compare the winters in Central Asia region. The third factor which affect India climate is pressure and wind. The climate and associated weather conditions in the India are governed by you know, following atmospheric conditions. First is the pressure and surface winds, then upper air circulation, or also known as the jet stream, and third is the western cyclonic disturbance, which comes in the month of January, February, and they actually help in the rabi crops, in the cultivation of rabi crops like wheat, and then the tropical cyclones, which comes in the month of October, November in the eastern coast of India. So these are some of the very important factors, and these are some of the pressure and some of the winds which are very important in the Indian monsoon. And India lies in the region of actually northeasterly wind, and these northeasterly wind actually originate from the subtropical high pressure. See, these are the part of the you know the high the global wind system actually. In the equator actually the low pressure is created, and then at the region of around at the region of around 30-degree north and 30-degree south, these high pressure system is formed, and then at the region of around 60-degree north and south, this low pressure again formed. So actually there are various type of pressure belt present in the earth. We will see in the coming videos about all the pressure systems and the global winds present in the earth. Now, if you see that India lies in the region of northeasterly winds, and these winds actually originate from the subtropical high pressure belt of the northern hemisphere, and they blow towards the south, but they get deflected to the right because of the Coriolis force, and they move on towards the equator equatorial low pressure area, and these winds actually carry very little moisture because they originate and blow over land only, and they don't come in any river body or any water body don't come in between these winds, and that is why bring no rain or very little rain. See, this Coriolis force is actually an apparent force it caused because of the Earth's rotation, and Coriolis force is actually responsible for deflecting winds toward the right in the northern hemisphere and toward the left in the southern hemisphere. So please remember these facts, that whatever comes in the northern hemisphere, that wind will be you know deflected towards the right direction in the northern hemisphere and toward the left direction in the southern hemisphere. And this deflection of wind because of the earth rotation is also known as Ferrous Law. And the pressure and wind conditions over the India are very unique. And during winter, there is a high pressure area north of the Himalayas, and cold dry winds actually blow from this region to the low pressure areas over the oceans to the south. And in summer, actually, a low pressure area develops over interior Asia as well as over northwestern India, and this causes a complete reversal of the direction of wind towards during the summer. And actually the air moves from the high pressure area over the southern Indian Ocean in a southeasterly direction, and then it crosses the equator. I've told you, explained you all this process in the beginning of this chapter. And because of the Coriolis force, it turns towards right, and that is why it turns right towards the low pressure areas over the Indian subcontinent, and that is why these southeasterly winds they become the southwest monsoon winds, and these winds blow over the warm oceans and they gather moisture and bring widespread rainfall over the mainland of the India. So see, the phenomena is that the equator is the region where the intertropical convergence zone is formed. So intertropical convergence zone means the wind from the northeast and the wind from the southeast, they both converge at the equator or around the equator. Then because of the apparent movement of sun in the summer season, that ITCZ moved toward the north and it comes up to the Tibet plateau. That is why the whole wind system shifts towards the north. And south is wind. They were whatever winds were coming in the southern hemisphere. They will also try to move to cross. They will also try to cross equator. But whenever they will try to cross equator and they try to come in the northern hemisphere, the earth rotation effect will come into play. And I've already told you that because of the Coriolis force, whatever wind will come in the northern hemisphere, they will deflect toward the right. So because of this Coriolis force effect, the southeasterly wind which were flowing in the southern hemisphere, whenever they will try to cross the equator, they will be deflected towards the right, and that southeasterly wind will become the southwest wind, and these winds are known as the monsoon winds or the and these winds they appear to be coming from the southwest direction, and that is why they are known as the southwest monsoon winds. Now the second most important pressure and wind factor is the air circulation. And air circulation in this region is dominated by a westerly flow. Westerly means whatever this easterly or westerly, it means the origin of the point or origin of the wind is from the west. So that is why it is known as the westerly. It means it is coming from the west direction. An important component of this flow is the jet stream. Jet streams are located approximately over 27 degree to 30-degree north latitude, and that is why they are also known as subtropical westerly jet stream. And over India, actually, these jet streams blow south of the Himalayas, and they blow all around the year except in the summer. And the western cyclonic disturbance actually experienced in the north and northwestern part of the country, that is in the Himalaya, Punjab and the Haryana region. And these are because of the western cyclonic disturbance. And in summer, the subtropical westerly jet stream actually moves north of the Himalaya with the apparent movement of sun. I've told you this apparent movement of sun is this concept is very important, and there is no any reversal of wind. There is always a apparent movement of sun towards the north direction in the summer season, and apparent movement of sun in towards the south direction in the winter season. So an in easterly jet stream, also called the subtropical easterly jet stream, they blows over the peninsular India approximately over 14-degree north during the summer months. So the major winds which are having an effect in the monsoon, first is the pressure and wind conditions, and because of the tropical ITCZ movements and the apparent movement of sun towards the north. Then the second most important is the upper air circulation, that is known as jet stream or subtropical westerly jet stream. They brought western cyclonic disturbance in the north and northwest part of India. And then the other most important wind is the subtropical easterly jet stream, which blows over the peninsular India. Now see this definition. These jet stream are actually narrow belt of high altitude above 12 kilometer westerly winds in the troposphere, and their speed varies from around 110 km per hour in summer to about 184 km in the winter, and a number of separate jet streams have been identified, and the most constant are the mid-latitude and the subtropical jet stream. These are some of the facts related to the jet stream. Now, if you see this western cyclonic disturbance, this is very important in the north and in the west and northwest part of the India. They usually come in the winter months. They brought in because of the westerly flow from the Mediterranean region, and they come to they come along with the jet, subtropical jet stream. They usually influence the weather of the north and northwestern part of India. And another very important thing associated with the Indian monsoon is the tropical cyclone. They occur during the monsoon, during the end of the monsoon in the months of around October and November, and they are a part of easterly flow. Now, if you see the Indian monsoon, see the climate of India is strongly influenced by the monsoon winds, and whatever in the ancient time also the sailors who came to India, and they were the one of the first who have noticed the phenomena of the monsoon, and they've benefited from the reversal of the wind system as they came by sailing their ships at the mercy of the mountains, mercy of the winds. And the Arabs who had also come to India as traders named this seasonal reversal of the wind system monsoon. But I've told you that what is the reality of this monsoon. This monsoon is actually not the seasonal reversal. It is only the apparent movement of sun. Now, this figure is actually depicting the atmospheric conditions over the Indian subcontinent in the month of January. See, in the month of January, this subtropical westerly jet stream, it actually, blows in the south of the Himalaya, and these winds, you know, these north, these winds, around the region of the Tropic of Cancer, they blow from the northeast region, and some of the winds from the southeast region. Now, if you see closely the atmospheric conditions over the Indian subcontinent in the month of June, all the conditions have been the apparent movement of sun has been taken place, and the ITCZ has been moved towards the north, and that is why whatever winds they were flowing in the south, they were flowing in the southern hemisphere from the southeast direction. They will try to come to the in this come to this ITCZ, because they will try to converge in the ITCZ, and ITCZ has been moved up to the Tibetan plateau. So that is why whenever they will try to come into the northern hemisphere, because of the Coriolis effect, they will move towards the right. So they were going in the southeast direction, but they will move toward the right, and that is why their direction will be changed to the southwest, and that is why they are known as the southwest monsoon winds. And monsoons are actually experienced in the tropical area roughly between the 20-degree north and 20-degree south. And the mechanism of the monsoon, actually, to understand the mechanism of the monsoon, following five factors are very important. The first and the most important condition is the differential heating and cooling of land and water, because it creates low pressure on the landmass of the India. But while the seas around around experience comparatively high pressure. So because high pressure is present in the seas and low pressure is present in the land mass, so the wind will move from high to low, and that is why the monsoon wind will be attracted toward the low pressure of the land, or low pressure of the India. So this differential heating and cooling of land and water is very necessary condition. Then the shift of the position of ITCZ, I have told you many times. In summer season, over the Ganga plain, or over the region of the near the region of the Tibetan plateau, usually ITCZ is positioned around 5 degree north of the equator, and it is also known as the monsoon trough during the monsoon season. Now, the third important condition is the high pressure area east of the Madagascar. Madagascar is actually present in the Indian Ocean region, and it is actually present in the southeast of the African continent, and Madagascar is a separate island country of Africa. And because of the high pressure, created at the east of the Madagascar, approximately at 20 degrees south in the Indian Ocean, the intensity and position of this high pressure area is very important for the Indian monsoon, because as much as high pressure is created in this Madagascar, it will push more and more southwest winds towards the India, and that is why there will be more rainfall in the India. Then the fourth factor is the Tibetan plateau. It needs to, heat. It needs to be heated intensely during the summer season, and which results in the strong vertical air current. And because if this Tibetan plateau will be heated, then because it will heat, then the strong vertical air currents will be formed, and the formation of low pressure over the Tibetan plateau will take place at about 9 kilometers above the sea level. And then the movement of westerly jet stream to the north of the Himalayas, and the presence of the tropical easterly jet stream over the Indian peninsula during the summer. So these are some of the factors very important for the Indian monsoon formation. And to understand the mechanism of the monsoon, we all need to remember all these factors. Now, ITCZ, I've already told you, it is a broad trough of low pressure in the equatorial latitudes, and here the north is the southeast trade winds converge, and this convergence zone lies more or less parallel to the equator, and it moves north or south with the apparent movement of the sun. Either in the summer season it moves towards the north, and in the winter season it will move toward the south. And apart from all this, it has also been noticed that changes in the pressure condition over the southern ocean affect the monsoon. And normally, whenever the tropical eastern South Pacific Ocean experience high pressure, the tropical eastern Indian Ocean experience low pressure. So the eastern South Pacific Ocean actually experience the high pressure, and the eastern Indian Ocean experience the low pressure. But in certain years there is a reversal in the pressure conditions, and the eastern Pacific has low pressure in comparison to the eastern Indian Ocean. And this periodic change in the pressure condition is known as the southern oscillation, or SO. And this difference in the pressure over the Tahiti or the Pacific Ocean, and the Darwin in the northern Australia, that is Indian Ocean, is computed to predict the intensity of the monsoon. And if the pressure difference were negative, it means that the below average and the late monsoons will be observed in the India. And the feature connected with the SO or the southern oscillation is known as El Nino. El Nino phenomena takes place. El Nino means a warm ocean current will flow towards the Peruvian coast. See, in the normal condition near the Peruvian coast, the cold current will be passed, and the up because of the upstream takes place near the Peruvian coast. A heavy amount of fishing will take place, and the fishing business will be very fruitful and profitable near the Peruvian coast. And there will be actually a Walker cell will be present in the whole Pacific Ocean. There will be high pressure near the Australia region, and that results in the good rainfall over the southeastern part of the Southeast Asia, and some of the South Asian countries. And the cold, cool conditions or the winter conditions will be present at the Peruvian coast. But because of the El Nino, It is actually warm ocean current, and it actually reverses the normal condition. That is, the low pressure will be formed near the Peruvian coast, and the high pressure will be formed near the Australia coast. And it actually happens every 2 to 5 years, and this changes in the pressure conditions are connected to the El Nino. We will see what is the El Nino and La Nina in the next video, in some of the video, and that is why this whole phenomenon is known as the ENSO. El Nino is actually a name given to a periodic development of a warm ocean current. I've told you this. So El Nino is a warm ocean current along the coast of the Peru. Please remember this, and it acts as a temporary replacement of a cold Peruvian current. And El Nino is actually a Spanish word. It means the child, or and refers to the baby Christ. As this current starts flowing during the Christmas, in the Australia, because the Christmas in the Australia, is celebrated in the summer month. And the presence of El Nino, it leads to an increase in the sea surface temperature and weakening of the trade winds in the region. See the onset of the monsoon and the withdrawal. See the monsoon winds are not steady winds but are pulsating in nature, and they are affected by various atmospheric conditions encountered by it on its way over the warm tropical seas. And duration of monsoon is around 100 to 120 days, and it usually happens from early June to mid September. And around the time of its arrival, the normal rainfall actually increases very suddenly, and it continues constantly for several days, and this process known as the burst of the monsoon. Burst means it actually it comes suddenly and then continues constantly. And this burst and the pre-monsoon showers are different. See, pre-monsoon showers are only like a trial of the monsoon, a trailer of the monsoon. But this burst is actually this is very spontaneous activity for some it's spontaneous activity, and it rainfalls continuously for some days. So this is known as a burst. And monsoon arrival arrives at the southern tip of the Indian peninsula by the first week of the June. We'll see in the next page the arrival of the monsoon, and then it bifurcate into two branches. First is the Arabian Sea branch, and the second is the Bay of Bengal branch. And Arabian Sea branch actually it reaches the Mumbai about 10 days later. After approximately at around 10th of June, and this is fairly rapid advance. And the Bay of Bengal branch also advances rapidly, and it arrives in the Assam in the first week of the June. And lofty mountains which present in the Assam and northeast part of India, they causes the monsoon winds to reflect toward the west over the Ganga plains, and by mid-June, this Arabian Sea branch of the monsoon arrives over the Saurashtra Kutch region of the Gujarat and central part of the country. And then the Arabian Sea and the Bay of Bengal, they actually merge over the northwestern part of the Ganga plains, and the monsoon reaches the Delhi at around 29th of June, and then by the first week of July, western UP, Punjab, Haryana, and eastern Rajasthan, they experience monsoon. And by mid-July, it reaches the Himachal Pradesh and rest of the country. You can see in this figure 4.3. See, this monsoon, winds, they start from the Kerala coast, and they will come at around 1 June. Then they will bifurcate into two branches. First is the Arabian Sea branch, then the Bay of Bengal branch. See, this is the Bay of Bengal branch. It also comes in the first June, and then they will move towards the west, like then first June, then 5 June in the Meghalaya region, and then in the Arabian Sea branch, it will move towards the north, and It will move towards the Gujarat and Saurashtra Kutch region on the 15th June. Then on the 1st July, it will move toward the eastern Rajasthan, and on the 15th July, it will move toward the western Rajasthan. And this is the diagram, and it is showing the variation of the advancing monsoon actually. And then the withdrawal or the retreat of the monsoon takes place, and it is a more gradual process. And withdrawal of the monsoon actually begins in the northwestern part of the India by early September. So northwestern states of the India, they actually that monsoon reaches very late, and the monsoon don't remain for the longer time. And the withdrawal of the monsoon begins from the northwest states. That is why they are the most arid regions of the India. And by mid-October, it withdraws completely from the northern half of the peninsula. And the withdrawal from the southern half of the peninsula is fairly rapid. And by early December, the monsoon has withdrawn from the rest of the country. Now, the island which present in the Bay of Bengal, that is the Andaman and Nicobar Island, they receive actually the first monsoon showers progressively from the south to north from the last week of April to the first week of May, and then withdrawal also they takes place progressively from north to south from the first week of December to the first week of January. Now this monsoon, we will see the seasons which according to the Indian Meteorological Department, four seasons can be identified in India. That is, first is the cold weather season. The characteristic of the cold weather season is the warm day and the cold night. Then second is the hot weather season. Then third is the advancing monsoon. It happens in the June to September. Then retreating monsoon, that is October to November. And the cold season, it takes place from December to February. Then hot season, this means the summer season, from the March to May. Now, see, the coastal areas, they don't actually experience much variation in temperature because of the moderating effect of seas, but there is a variation in the rainfall present. And the seasons are, these are particularly noticeable in the interior parts of the country, and most importantly in the northern plains of Ganga and Indus and northern part of the country. So this cold weather season, it is also known as the winter, and this cold weather season actually begins from mid-November in the North India and it stays till February. December and January are the coldest month in the northern part of India, and temperature decreases from the south to the north. And average temperature of Chennai on the eastern coast is around 24 to 25 degrees Celsius. But in the northern place, it may reach, up to 10 degree or even below than the 10 degrees Celsius. I've told you these are the most important characteristic of the cold weather season. That is, the days are warm and the nights are cold. Please remember this. And frost is very common in the north and the higher slopes of the Himalayas. They experience snowfall also. And during this winter season, the northeast trade winds actually prevail over the country and they blow from land to sea. And hence, for most part of the country, it is a dry season. So the northeast trade winds, they actually prevails in the winter season of the India. But they are the dry winds, but some amount of rainfall occurs on the Tamil Nadu coast because these winds, northeast winds, they will pass through the Bay of Bengal. So because of the water, moisture present in the atmosphere of the Bay of Bengal, they will collect the moisture, and that is why they will bring rainfall in the Tamil Nadu coast. And in the northern part of the country, a feeble high pressure region develops with light winds moving outwards from this area, and influenced by the relief, these winds blow through the Ganga Valley from the west and northwest. The weather is normally marked by the clear sky, low temperature and low humidity, and feeble variable winds. A characteristic feature of the cold weather season over the northern plains is the inflow of the cyclonic disturbance from the west and the northwest. And the low pressure system which originate over the Mediterranean Sea and the Western Asia and moves into the India as the western cyclonic disturbance. I've told you this. And they come along with the westerly flow. They causes the much needed winter rainfalls over the plains and snowfall in the mountains. Although the total amount of winter rainfall, it also known as Mahavat, is very small, but they are very important for the rabi crops and particularly the wheat crops. Wheat actually. In peninsular region, they don't have a well-defined cold season, and there is hardly any noticeable seasonal change in the change in the temperature pattern during winters because of the moderating influence of the sea. I've told you that there are two type of breezes. First is the sea breeze, and second is the land breeze. And because of these two breezes, travel in the day and night time, the coastal areas they are having very moderate climate, and temperature variation don't take place in the coastal region. Then the second important season is the hot weather season, that is the summer season. See, because of the apparent northward movement of the sun, the global heat belt shift northward. I have told you this, and from the March to May, it is very hot weather season in the India, and the influence of the shifting of the heat belt can be seen clearly from the temperature records. In the various parts of the country, it may reach up to 50 degrees Celsius also. But in peninsular India, temperature remains lower because of the moderating influence of the oceans. I've told you many times in this video itself. The summer months experience actually rising temperature and falling air pressure in the northern part of the country. And towards the end of the May, an elongated low pressure area develops in the region, extending from the Thar Desert in the northwest to Patna and Chotanagar Nagpur Plateau in the east. Now, a very striking feature of hot weather season is the Lu. They are the very strong gust sea and hot and dry winds they blow to during the day for the north and northwestern India in the parts of UP, Haryana and Punjab, and sometimes they even continue until the late in the evening, and direct exposure of this Lu may even prove to be fatal, and dust storms are very common during the month of May in the northern India. And these storms bring actually the temporary relief as they lower the temperature, and may also bring sometimes very light rainfall and the cool breeze. And this season is also the season for the localized thunderstorms which associated with the violent winds, torrential downpours, and often they accompanied by the hail also. And in the West Bengal region, these storms are known as the Kal Baisakhi. So in the western parts, the local winds like Lu formed in the summer region, and in the West Bengal, there are pre-thunderstorm, pre-monsoon thunderstorm. They are known as the Kal Baisakhi. And towards the close of the summer season, pre-monsoon showers are common, especially in the Kerala and Karnataka region, and they help in the early ripening of the mangoes, and that is why they are referred to as the mango showers. So mango showers in the Kerala and Karnataka, then Kal Baisakhi thunderstorm in the West Bengal region, and then Lu, stormy and dusty and very hot wind in the western part of the India. So these are the two seasons, major seasons. Then third is the advancing monsoon or the rainy season. And by the early June, the low pressure condition over the northern plains intensify. So that is why, because of the low pressure, it attracts trade winds of the southern hemisphere, and the southeast trade winds which originated over the warm subtropical areas of the southern oceans. They cross the equator and blow in a southwesterly direction. I've told you all these things, and they enter the Indian peninsula as the southwest monsoon. and these winds blow over the warm oceans. That is why they bring abundant moisture to to the Indian subcontinent. And these winds are very strong and they blow at an average velocity of 30 km per hour. And with the exception of the extreme northwest, these monsoon winds they actually cover the entire India in about a month time. An inflow of the southwest monsoon into the India brings about a total change in the weather. And early in the season, the windward side of the Western Ghats they receive very heavy rainfall, even more than 250 centimeter. Then Deccan Plateau and parts of the Madhya Pradesh they actually lie in the leeward side of the Western Ghats. That is why they they receive very small amount of rainfall because of the rain shadow region. Although they receive some amount, maximum rainfall of this advancing season is received in the northeast part of the country, and Mawsynram is the place in the southern region of the in the southern ranges of the Khasi Hills that receive the highest average rainfall in the world. And rainfall in the Ganga Valley it actually decreases from the east to the west, and Rajasthan and the parts of Gujarat they get very scanty rainfall. Now another phenomenon which associated with the monsoon is the tendency to have breaks in the rainfall, and it has actually wet and dry spells. See, monsoon rains takes place only for a few days at a time, and then they will take the breaks. And these are, these breaks are actually related for because to the movement of the monsoon trough. See, this trough keeps moving, and that is why when the trough and its axis keeps on, moving northward or southward, and which actually determines the spatial distribution of rainfall. When the axis of the monsoon trough lies over the plains, rainfall is very good in this part. But when the axis shifts closer to the Himalaya, there are the dry spells in the plains, and that is why the widespread rain occurs in the mountainous catchment area of the Himalayan rivers. And these heavy rains actually bring in their wake devastating floods, and they cause damage to life and property. Then the frequency and intensity of tropical depressions too determine the amount and duration of monsoon rains, and these depressions form at the head of the Bay of Bengal and they cross over to the mainland. So these tropical cyclones actually formed in the Bay of most of the tropical cyclones formed in the region of the Bay of Bengal in the eastern coast of the India, and the depressions follow the axis of the monsoon trough of the low pressure, and that is why the monsoon is known for its uncertainty. And the alteration of dry and wet spells they vary in intensity, frequency, and duration, and it may cause heavy flood in one part, but it may be responsible for the drought in another. Now we will see the this map of advancing monsoon. We have already seen this map. Now we will see the map of this retreating monsoon. That is, the monsoon is getting back, and it actually starts from the northwest part of the India, that is from the regions of Rajasthan. We can see this first September. From the starting of the September, this monsoon is retreated. Then in at the on the 15th September, the rainfall from the regions of Punjab and Jaipur and Gujarat. Then October, and then these on the 15th October, then 1 November, then 15 November on, and on the December. At the end of the December, the rainfall completely vanishes from the Indian continent. Then the last season is the retreating or the post-monsoon, that is the transition season. It happens in the October, November, and it happens because the apparent movement of sun is towards the south, and that is why the monsoon trough or the low pressure trough over the northern plain it becomes weaker, and that is why this is gradually replaced by the high pressure system, and southwest monsoon weakens and they starts withdrawing gradually. And by the beginning of the October, the monsoon draws from the northern plain, and months of October, November, they form a period of transition from hot rainy season to dry winter season, dry winter condition, and the retreat of the monsoon is marked by the clear sky and rise in the temperature. Now, days temperature are very high, but nights are cool and pleasant. The land is still moist, and then because of the conditions of high temperature and humidity, the weather becomes rather oppressive during the day, and this is known as the October heat. So please remember this: October heat means the conditions of high temperature and humidity, weather become very oppressive. And in the this in the second part of the October, the mercury begins to fall rapidly in the northern India. These are the four major seasons of the India, and cyclones are actually happened in the eastern coast of the India in the deltas of Godavari, Krishna, Kaveri, and also sometimes cyclone arrives at the coast of the Odisha, West Bengal, and Bangladesh. And the bulk of the rainfall of the Coromandel coast is derived from the depressions and cyclones. And distribution of rainfall, if you see that it varies from the 400 centimeter of rainfall in the some parts of the Western Ghats and the northeast part to the to less than 60 centimeter in the western Rajasthan and the adjoining part of the Gujarat, Haryana, and Punjab. And rainfall is equally low in the interior of the Deccan Plateau and east of the Sahyadris. So the regions, the variability in the rainfall is very high in the India, and low precipitation is found in also in the Leh in the Jammu and Kashmir region, and the rest of the country actually receive the moderate rainfall. Snowfall is only happen in the Himalaya region. So there are three regions which are having very low rainfall. They are the western Rajasthan, then parts of the Gujarat, Haryana, and Punjab, and then the Leh region in the Jammu and Kashmir. And owing to the nature of the monsoon, the annual rainfall is highly variable from year to year, and this variability is high in the regions of low rainfall, such as parts of Rajasthan, Gujarat, and leeward side of the sea. Leeward, and there are two sides of the Western Ghats. First is the windward side, which actually is whenever the southwest monsoon it strikes the Western Ghats, that side is known as the windward side, and the side opposite to the windward side is known as the leeward side. So rainfall is very high in the windward side, but is very low in the leeward side, because as all the moisture will be poured in the form of the rainfall in the windward side. So whenever these winds will move, will cross the Western Ghats and move to, in the leeward side, the moisture content will be very less, and that is why they will bring very less rainfall in the leeward side. And monsoon is a unifying bond, because the ancient tribals also they took the help of the monsoon to come to India, and also then they waited for the monsoon to end so that they can move, they can move from the India. The Arab traders also, and there are various type of unifying factors, because Himalaya protect the subcontinent from extremely cold winds from Central Asia, and this enables northern India to have uniformly higher temperature when compared to other areas on the same latitude. And similarly, the peninsular plateau under the influence of sea from three sides like the Arabian Sea, Bay of Bengal Sea, then Indian Ocean, they have moderating temperature. And despite such moderating influences, there are greater variations in the temperature conditions. But nevertheless, the unifying influence of the monsoon on the Indian subcontinent is quite perceptible, and the seasonal alteration of the wind systems and the associated with weather condition provide a rhythmic cycle of seasons. Now, if you see, these are the very important diagrams. This map is depicting the seasonal rainfall from June to September for the advancing monsoon. So you can see that above 400 centimeter monsoon is observed in the some parts of the Western Ghats and in the windward side, and then some parts of the northeast in the Meghalaya region. Then from the 200 to 400 degree, 200 to 400 centimeter, the areas surrounding this 400 in the Western Ghats and the northeast, and then 100 to 200. You can observe this diagram. The color coding is defined. The very low rainfall regions are Thar Desert in the western part of the India, and some of the parts of the leeward side of Western Ghat, and also the some of the parts of the Leh region in the Jammu and Kashmir. Then this is the annual rainfall, it means the average rainfall annually in the regions. Here also you can see that above 400 is observed in the Western Ghats in the windward side and some of the regions of the northeast states. Then the surrounding regions of 400 centimeter, of the Western Ghats and the northeast, they are having 200 to 400 centimeter. See the Andaman and Nicobar, they are having the rainfall above 400 centimeter, and then you can see all the other rainfalls. So this is actually the end of this chapter. We will see the multiple choice exercise in this video, and because this video is quite long, so we will see all the other exercise in the next video. We will make a separate video for the exercises. We can see, but the objective questions here. That first question is the which one of the following places receive the highest rainfall in the world? It is Monsoon. So first will be B. The wind blowing in the northern plain in the summer is known as the Lu. So second will be B. Then which one of the following causes rainfall during winter in the northwestern part of the India? It is western disturbances which come from the Mediterranean region. We have already seen this, and these are very useful for the rabi crops, especially wheat. So third would be C. Monsoon arrives in India approximately early June. We have seen that it enters in the Kerala coast. Then which of the following characterizes the cold weather season of India? It is warm days and cold nights. Now we can see one or two questions of this also, that the controls which affecting the climate of India are the altitude, latitude, pressure and wind system, and there are six total controls. We'll make a separate video for this. So thank you for listening. Please like, share and subscribe our channel Study for Civil Services for more updates. Thank you for listening.